Rita Paradiso mentioned before, when we look at the Wealthy or My Art or related project like this, which measure physiological measurements, which perform with physiological measurements, we have ECG, respiration signal, body temperature, and so on that are extracted. In other projects, and I will mention one of them in a while, we try to do also biosensing or biochemical, at least biochemical sensing. And then, of course, the goal would be to combine all of this information. As I said before, we cannot expect to have as good signal as when we are by the physician. First of all, we allow the person to put themselves the garments on her, or on she or he, and so we have no control of the positioning of the sensors. And second thing, very important, we don't ask the person to be inactive during the measurements, which means that we are in the worst possible case, so during the normal activity. But nevertheless, what we can do is to measure more parameters because we have access to a larger surface of the body, and we can combine them with other new coming or possible sensors in order to get the missing information, or at least to fill the gap when the physician is not there. And when we look at the context, I should have said rather to the environment in this case, since some parameters are also combined before, we look at the environment of the person, we look also at the activity of the person, and we look at the other parameters around him. So I mentioned before that we try to extend with new sensor type what we measure with physiological signals. So we aim at several types of application or disease sometimes, and sometimes just for sports or normal activity or more intensive, and measuring not only electrical signal but also in different ways, for instance optical signal or chemical reaction or biosensing even. And you have here the list of sensor and sensing techniques that we used in the case of the BIOTEX project, which aimed at this, to extend the type of measurement that we can do. So when we look at the optical, what we do optical spectroscopy, we do optical immunosensing, for instance, for wound healing application. We do optical colorimetry for measuring the pH inside of the sweat. We do also impedance measurements, or conductivity or sweat rate directly in the sweat. And last one, electrochemical reaction inside of the sweat to detect chloride, sodium, or potassium ions. So this is what we aimed in the BIOTEX project. We are now in the period that we started tests in the field, so on people, healthy and sick people, volunteers, so pilot tests on a few person per application, and I cannot provide yet the results. What I can tell you is that to go to that stage, we verified before that in the lab we had sufficient quality of signal and that it was suited for the application. Okay, just some example about what we can do or what we did in the past concerning the monitoring. As I mentioned before, tele-alarm was one of the first systems that is still available, by the way. And then what was possible to have simply was just to have a fall detection system that was mentioned this morning, done also by others, in order to have an automatic alarm in case of fall. Something more complex that was related before by Rita Paradiso was to sense more ECG, impedance, piezo bands for movement, to measure also oximetry, in this case we're using standard sensors, and to start extracting parameters. This was the case of the Wealthy project. With another project that I know, we had this more impressive list of sensors because of the different types, but as you can see, less channel of each, except in one case for movements. And we could extract heart rate, respiration rate, ECG features, breath rate, breath amplitude, and also activity information directly on body, just using the signal from the sensors avoiding whenever possible to transmit this information further, as I said before, for cost reason, and also because we don't want somebody behind each patient or each user just to look at the data. Okay, when I look closer at the parameter extraction, I made up this matrix of this table that allows to understand a little bit and allows me to explain where are the difficulty or the challenge. So at the bottom, see, this is kind of, I would say, layer representation of the system, similar for the people who are working in telecommunication to the ISO layer system. So you have at the bottom the body with the skin, and where you put your sensors, your garment. This is the second layer, what I call the sensor layer, where we have garment on one side and sensors embedded or sometimes added. Then the conditioning, that is to, from this signal, make them available or make them out of the noise in order to allow to extract the good information that will be done later in the next layer, and do some local signal processing already to filter them and to combine whenever possible with previous information, for instance, from the same signal. Then on the other layer, on the processing layer, extract global feature like, for instance, the activity of the person, and not only acceleration signals which look like noise, or, for instance, extract the heart rate of the person, not just the ECG, and not just looking at the ECG, and try to provide more insight about the overall outcome of this person. And on the top layer, what is done usually mainly offline today, is provide already user interaction capability, that is provide him a display, provide him information on his mobile phone in a way or another, in order for him to really to know about it and maybe not have to transmit to anybody. If you are a jogger, you are maybe not interested to download your data on the internet, except if you want to compare with friends and so on, but you don't need somebody looking at your information, although it could be useful if you have an external coach that could coach you, in this case, about it. And of course, in the case of healthcare, it's even more important, especially if you have some health problems. It was mentioned this morning. Many people do feature extraction from activities, so you can extract some classes. For instance, in this signal, the person was at rest, then start walking, stop walking, lie on the floor. You can see here, he would have run, probably, and then